The topic today is Intro to the Transformations with a Quadratic Function, and we want you to be able to describe the transformation that happens. This is a very important slide for you to write down in its entirety. I do also have the PDF posted on my website, so if you wanted to look at it there, or just pause and write. So what we have is that parent function f of x equals x squared. If you remember, the shape of that graph is a U, which we call a parabola. Now we're going to introduce these transformations. The first transformation is if you have an f of x, x minus h, so it's inside the function, something like y equals x plus x minus 5 squared, what that does is it moves that graph to the right 5 units. So that would be the description, right 5 units. If you were to have a function with a plus h, so something like y equals x plus 2 all squared, notice what will happen is we will take this parabola and shift it left 2 units. And I said in this parentheses here, so please make sure you're careful here. Think opposite. So when you see a minus, you shift it to the right. If you see a plus, shift it to the left. The second transformation is your vertical shifts up and down. These are at the end of the function. So if you have something like y equals x squared plus 3, it's going to shift it up 3 units. If you have something in the second one, x squared minus 4, it's going to shift it down 4 units. So the description for these types are vertical shift up 3 units or vertical shift down 4 units. Now we're talking the red transformations. Those are our reflections. There's a difference between the two. There's a reflect about the y-axis, reflect about the x-axis. If you have a function that looks like y equals negative x squared, it's going to reflect about the y-axis. If you have a function that looks like this, y equals negative, in front of the function, it's going to reflect about the x-axis. So those would be the descriptions. Reflect about the y-axis, reflect about the x-axis. The last two are your vertical compressions and stretches, your horizontal compressions and stretches. So if we have a multiplier in front of the function, like this, y equals 3x squared, it's going to be a vertical stretch. So we'd say stretch vertically by 3. If you have a fraction that's in front of the function, something like this, y equals 1/2 x squared, it's a compression vertically. Compress by 1/2. And that's how you would describe them, what I have written in the red. Vertical stretch by 3, vertical compression by 1/2. The next set is your horizontal stretches and compressions. If your b is greater than 1 and it's inside the function, it's going to be a stretch away from the y-axis, and we say it's a horizontal stretch. And if you have a fraction, then that's also 1 over b, and that's a compression. So let's say my b was 4. So notice where that b goes. It goes inside the function. So something like this, y equals 1/4 x squared. You're flipping it, reciprocating it, and that's why I have in here reciprocate, and it's inside the function. You would say it is a horizontal stretch by 4. The last example is if you have a b that is a fraction, let's say 1/3. Again, you want to reciprocate it inside the function. So that reciprocation would be 3/1, or 3. And that's going to be a horizontal compression by 1/3. Now in this example, this probably looks pretty familiar to you. We've graphed some functions that are quadratics, and I want you to describe the transformation. So that would be focusing on this last slide. All of these things can happen. So let's talk about this piece right here, plus 5. That's inside the function. So the description is going to move to the left 5. Then this minus 4 is outside the function. It's going to shift it down 4. And then this negative reflects it about the, so notice again, I'm looking at the slides. Where is it? The negative is in front of the function, so it's reflecting about the x-axis. Okay. How we find our critical point is this piece and this piece. So we're going to go left 5, so that's negative 5, and down 4, negative 4. And how we would graph this is we would start with our negative 5, negative 4. Here's negative 5, negative 4. And there's our first point, negative 5, negative 4. And now we pick a value on the x-axis to the right and to the left, 1. So negative 4 and negative 6. And to find out what those ordered pairs are, we evaluate the original function in the red here. So my function is y equals negative x plus 5 squared minus 4. So negative x is negative 4 plus 5 squared minus 4. And we would simplify this. Negative 4 plus 5 is 1. Squared is 1. We have a negative in front. So negative 1 minus 4 is negative 5. What happens every time is when you move one right and one left, you're going to get the same answer here and there. If you wanted to evaluate it for negative 6, you definitely can. So now if we go out and graph those 2 points, negative 4, negative 5, and then negative 6, negative 5. There's the shape of the graph starting out. Now we're going to go 2 right and 2 left from the center. So remember, this is our center, negative 5. Now we're going to go to negative 3 and negative 7. We again evaluate it, negative 3 and negative 7 in the original function. So negative, replace the x with negative 3 plus 5 squared minus 4. Negative 3 plus 5 is 2, squared is 4, with a negative in front is a negative 4, minus 4 is negative 8. Negative 8, this one also has to be negative 8 because of that symmetry. So if we graph those 2 points, negative 3, negative 8, negative 7, negative 8. So now our overall graph of our quadratic function looks like this. It opens down, it has those points, we found it using the transformations. I just want to go through one more example. Now we're just going to take the time just to describe it. If you wanted to go further and actually go out and graph it, you could definitely do so. So minus 6 inside the function, you have to think opposite. We're going to go to the right, 6 units. If you notice over here, there's nothing out in front. So we're not shifting it up at all. And then this 3, if we go back 2 slides, that 3 is in front of the function. So if we come down here in the green, is it greater than 1? Yes. So how we say that is the vertical stretch by whatever that multiplier is. So it's a vertical stretch by 3. We've now just described it. Vertical stretch by 3, right 6. If we wanted to find the critical point, we only focus on the shifts right and left and up and down. There is nothing here to move it left, up and down, but we need to move it right 6. Our critical point will be 6, 0. Then if we wanted to take the time to graph it, we definitely could do so.